I alluded to this type of problem earlier in a previous example, but let me walk you through what this leads us to in terms of another property. Here we have y to the fourth raised to the fifth power. So if we examine from starting from here, this 5 exponent means take 5 of those and multiply them together. So there's 1, 2, 3, 4, 5. So now the question is, how many y's are being multiplied together? Well, there's, if you count those up, or use a previous property here, there's 20 of them. And so the question is, how is that 20 related to those exponents? And there's a multiplying here going on. In other words, when you have a base with an exponent and you raise that entire thing with an exponent, the resulting number of bases being multiplied is simply the multiplication of those exponents. So again, 5 of those, and let's multiply. So here's another example. If I have x squared, raise that to the 10th power. The short version is 10 of these guys, really meaning 10 times 2 here, number of exponents. I'm sorry, number of x's being multiplied. So there's really 20 x's being multiplied here, and that's the short version, or the answer to this simplifying. So here's another rule. If I take a and raise that to an m power, and I raise that entire thing to an n power, how many a's are being multiplied here? Well, m times n of them times there. That's an n. So that's another rule of exponents.